And I'm going to share my screen, I think. And people should be able to see my PowerPoint now. And can everyone see that? In good shape, thanks. So thank you, Lauren, for the intro. So today's-
Steve, can I interrupt really quickly? We can see your slides, but we see the presenter view. I don't know if that was on purpose or not.
No, not on purpose. So let's see if we can change that. 1 second. Sorry. When I switched to presenter, it goofed me up. Let's try that again here. We'll do it this way, okay. Now let me try this again. How about that? Is that better?
Perfect, yep.
Right. Okay, thanks everyone. Today we're going to go over the promising practices guidelines. We're going to talk about what the promising practices are and where they come from. And I'm going to go over the solar integration guidelines. And this is not a workshop to explain how to integrate solar into affordable housing. It's a workshop to tell you about the guidelines for doing that. So I'm going to go over some parts of it fairly quickly. Also interested in getting your questions, concerns, and suggestions so that we can improve the guidelines that I will be going over. And as Lauren mentioned, here are the other workshops coming up on promising practices. And so the next one is next week, same time and day for domestic hot water. And then early integrated design and balanced ventilation. And the domestic hot water will also cover water distribution design and water conservation. So look for that. And as Lauren said, you can register on the HDC website. So I'm interested in learning who's in the room, in the Zoom room. So we're going to do a little poll, which you should see on your screen now. And if you would answer, there's 3 questions, we'll get an idea who's in the room. And that will help me direct the presentation. And that last question, sorry, it's an old, it should, how likely are you to use, to maximize solar in your buildings today? That's what that should say. This is from our last webinar. So if you can answer it that way, that'd be great. And when you've all answered, Lauren will share the results with us so we can see.
Nearly there.
Okay, great. Okay, why don't we share the results, not hold this up too much. Thanks, Lauren. So about a quarter of you are architects and half are developers, another roughly quarter engineers, consultants. Perfect. So we'll keep that in mind. And then 100% are involved in design and development. That's great to know. And looks like about 3/4 are interested in using solar on your developments, and 1/3 are somewhat likely. So maybe we can improve that, but great. So moving along. So the promising practices workshops are an outgrowth of the Exemplary Building Task Force. And this is a group of architects and engineers and developers and contractors coordinated by HDC to look at what the exemplary buildings of the future are and how to really drive the costs down as we build more and better buildings that will be required by our code in the future. So the promising practices are, as you can see from the workshops, we've broken it into different areas that relate to the guidelines we are putting out, solar being one of them. Others, as you heard, are around water and wall assemblies and likewise. So what we want to be sure everyone understands is that we're really trying to advance the practice of building affordable buildings and building them sustainably and cost effectively. So we want to emphasize that this, we hope and we believe these are relevant to all housing, not just exemplary buildings. So, you know, the exemplary building is doing all of the above, but we want you all to be clear that use this as a menu and pick and choose and learn from the demonstration projects we've done and the work we put into it. We hope it will be beneficial to everyone who works on design and development of buildings, of which you all do. So today's focus is on solar integration. So I want to start with talking about maximizing solar in affordable housing. So solar's been used on affordable housing, many projects for many years. Sometimes there's a little, sometimes a lot, sometimes there's none. But why maximize it? Why really build it out? And the key points are that solar gives you predictable electric savings over 30 years or longer. So 30 years the life of solar panels typically. And unlike energy efficiency and other things which can be impacted by behavior and maintenance and all kinds of things, solar is probably the most predictable investment you can make in sustainability. So it gives you a sort of almost guaranteed savings into the future. And with those savings on electricity, it protects you from future escalating electric rates. So as rates go up, that electricity you're saving is more valuable. And rates in Seattle City Light territory have been going up about 3.5% a year. So, you know, essentially, I think I've looked out 30 years, you know, the rates will be double or more what they are today. So think of that investment today, just the electricity you're generating doubles in value. And the other good news, and we'll go through this in more detail, is that you can create a positive cash flow considering the investment in solar after using tax credits and other incentives. So that just means it's a good investment from a financial perspective. And then why do it during new construction? So, you know, a lot of discussion around solar ready, and as long as it's ready to go, I can just build it anytime. And the keys here are at the time of construction, it's the lowest cost of install, right? Your contractors are all set up to do it. You have a crane at the building typically. There's you know, the roofing is being done. So it's lowest cost, and you'll see later, we'll share some numbers that there are two parts of this. Installing any solar is low cost. And once you're mobilized to do some solar, doing more solar is even lower cost. So, and being someone who tried building solar retrofits on existing buildings and learning that coordinating with the age of the roof and all kinds of other things was really difficult. This is really important. Another piece of this is the tax incentives that are eligible for solar, be they low-income housing tax credits or investment tax credits for solar, can be integrated into your whole building financing strategy. And you know, essentially, you're sitting down with building with your financing team, with your legal team, with your investors, and if you're going to do anything related to investments, this is clearly the time to do it. And finally, coordinating with a new roof install and the warranty. So making sure that your solar project works well with the roof choice and is integral. It also just so happens the life of solar panels and the life of roofs are pretty similar. So coordinating them with a new construction is really an opportune time to do it. And this is all in the guideline. I'm essentially going through some of the key points of the guidelines. You know, a study by the Solar Industry Association really found that much of the cost of solar is in the process. It's in supply chain, overhead, getting stuff to the site and margin. So if we're going to save money and drive the cost of solar down for affordable housing or anywhere, it's going to come from savings in the process, not the product itself. Solar panels have come down tremendously in price, but a majority of the cost is in other things, not the panels themselves. So this is in the guideline. We spent a lot of time working on process because in the past, solar is often comes sort of after the fact or after you consider the quote most important parts of the development, and solar is an option, so it is treated that way often. But to really get the benefits of solar and keep the costs down, it's important to follow a streamlined process, but also integrate it into all of the other development work you're doing on a building. So I'm just going to touch on a few of these. The most important is in the first conceptual phase of the project. And key is engaging with a solar advisor, and the advisor can be a solar designer or a contractor early and make them part of your conceptual integrated design team. Include solar in the concept design costing at the very beginning, not as kind of an afterthought. Think about strategy for the roof use. Roofs, there's a lot going on a roof, and there are a lot of choices to make and I'll go into that a little bit later, of all these different options and things that go on the roof. So it's what goes on the roof and what doesn't, but then also where does it go on the roof and how can we design around it so that we can put more solar up on the roof more cost effectively. I touched a little earlier on the financing strategy. How are you going to pay for this? And then there's options for ownership. So typically, and we'll focus mostly on owning it through the LLC that you'll set up for tax credit investment, but there are other options as well, lease back options and so on that could be explored and need to be explored early on. And then the final piece, and I'll spend a lot of time going over this later, is a conceptual pro forma. So there's an Excel spreadsheet that you can sort of play some what ifs. What if I use tax credits, low income housing tax credits or not, or investment tax credits? If I double the size of the system, what's the incremental cost and benefit and so on? So we try to develop this tool so that at the time you're conceptualizing the project, you can also do the what ifs for the solar. And then this next phase is really making the decisions around what you've come out of the concept with and design development. I'm not going to go into these too much. But these are in the guidelines. Also in the guidelines are, what is a solar system and what are the sort of the products and what are the best practices? And there are a lot of different products out there, and we've just tried to provide here some standards for how are you certain you're getting good quality product. This next piece is important. How much should you put on the roof? So the total solar resource fraction is the available solar energy that's available, how much sunlight hits the roof through the course of a day, through the course of a year, as well as the tilt and orientation of the panels. So, you know, are you, is it a flat roof? How are you going to use the panels and so on? So this really avoids falling into the trap of putting solar on parts of a roof that are just not going to be cost effective. And we believe like a 90% minimum is what you should look at. And the question for roofs may not be all or nothing. Some roofs may be partially shaded and have 90% resource fraction potential in one part of the roof and less on another part of the roof. So don't view shading as a total deal killer, but assess it carefully. And then modules come in various efficiencies, and we're suggesting here that looking at an 18% minimum, and you can get much higher, but it comes with higher costs, and you need to be careful that you don't reach a point of diminishing returns where you're paying a lot more for a little more efficiency there. And then we talk about inverters and so on. I'll point out monitoring because projects I've worked on, this has become a challenge sometimes. There are certain monitors, and the one I've worked with most is eGauge, that are utility grade. And if you work with utility programs or the purchase of renewable energy credits, it typically requires utility grade monitoring. They're not a lot more expensive, but you need to select the right monitor. So recommend a utility grade monitor on all buildings to be certain you're covered. Talk about racking and what kind of racking to use. And then here's a cost, a very rough sort of cost guideline. You know, it's important to, since a lot of projects don't deal with solar a lot, we wanted to share some general idea of what things should cost. And what you have here is if, you know, if you build a small system of some kind, because maybe you're trying to get points on your, for your low-income tax credits or score points for meeting code or other things, your first part of your system in an anchor system could cost $5 a watt. But when you get over that minimum, when you're already mobilized on a roof, when the solar contractor is already creating a project and has to do design, adding incremental is much less expensive, as you can see here. And that's just really the cost of having install and product, and all that overhead that goes with a project is already sort of paid for in the base. So this is an anchored and a ballasted system, and we'll talk about a little bit later, show in the guidelines where you use each, and we'll also be able to show how to calculate what the returns are on these two different options. And then talk a little bit about modeling performance. Here, your solar contractor can tell you how much potential is there for your solar system with a tool called PV Watts. And this is specific to your location on the planet with respect to sunlight, and gives you kind of an authoritative view. And I explained how solar is pretty much a guaranteed savings, and this is a third-party tool that really assures that. So we're not going to go through this in detail, obviously, but what became really clear was that the competition for roof space and the use of roof space had a big impact on how much solar you put on a roof, how much it costs to put on a roof, and therefore how profitable it was for the housing owner. So these are guidelines giving an idea of when do you need to reinforce a roof structurally. And this, I want to emphasize, this isn't just for solar. So this has, as you can see, dealing with ventilation equipment on the roof, ventilation ducts, heating equipment, et cetera, the solar itself, plumbing, vents, and so on. So the idea here is what we wanted to share, and this was developed with some architects and engineers in the area, to some rough guidelines when you're sitting down at the conceptual phase of your building. You know, how do you figure out if it's a little cheaper to put my ventilation on the roof, but I lose 4 solar panels, is that a good trade-off? And very likely it is. But I'll also suggest that if there's an option to keep the equipment off the roof, then you have option for more solar. So this doesn't prescribe what to do, it just sort of lays out the different options and what is sort of the best alternative from a solar perspective, but might not be from an overall building project perspective. And I will just emphasize on, these are just guidelines, and you know, your structural engineer and mechanical engineers and others would need to weigh in on the specifics for a building. So the next section covers working with utility, net metering. Imagine most of you are familiar with that. So basically the utility will give you credit for all of the energy that's produced by solar panels up to the meter's usage in a year. So that's really important as we make buildings more efficient, especially if it's connected to a common area meter and the units are individually metered, that you can, in the past, you could get to a point where you could have a solar system that's bigger than your common area meter. With the new proposed Seattle code that will require all electric hot water heating, we had a pretty significant electric load back onto the common area meter, and you shouldn't have that problem. So important to remember, if that was a roadblock in the past, that may have disappeared now that we're doing more with electricity in the buildings. And net metering maxes out typically at 100 kilowatts. There's a special provision that the City Light has, Seattle City Light, for large solar that allows up to 250 kilowatts. And it was originally established for the Living Building Challenge projects, but it's now also available to affordable housing that meet high efficiency standards. And that's been moving around, and we'll update this guide to show you exactly what those standards are, but I believe they just relate to how many code points you're taking to demonstrate the efficiency of the building. So if you're building a highly efficient building and you want to put 125 kilowatts or kilowatts of solar on the roof, now that's possible, and to get net metered for that. If you're not net metered, CLC Light buys it back at a wholesale price, which is about 1/3 of the regular rate. So this is a good option for affordable housing to build bigger systems. Another great benefit offered by the utility is the Green Up program. And they are planning to launch a new program, we're told, in 2021. And this pays upfront $1,500 kilowatt for, that should be a watt, I believe, sorry, watt, for renewable energy credits. And essentially, they're prepaying for the energy you anticipate generating from your system. And they are tradable renewable energy credits, but your project gets paid 100% upfront. To be eligible, it needs to be at least 30 kW in size, up to 100 or larger, as I explained earlier. And they're offering this only to nonprofit affordable housing and other low-income service providers. So this is not available to anyone but you all and your buildings. We are, on a side note, we're pushing hard to to make this as predictable as possible so you can count on this for your projects, and hopefully to increase the amount of funds available in the Green Up program. Green Up is a voluntary program that ratepayers pay into to buy renewable energy credits. But we believe there's a huge opportunity to increase it. Then I'm not going to go into detail here because I am not a tax credit attorney or accountant, but there are two kinds of tax credits available for solar. There's an investment tax credit, and for next year, it's 22% of the cost. And in 2022, it goes down to 10% unless the federal government takes action. You know, this can be used by your tax credit investor that's buying low-income housing tax credits, and you can use them together. So then you can, as I mentioned, you can also use low-income housing tax credits, 9% or 3% or 4%. And there is the low-income housing tax credit is reduced somewhat by, I believe it's half of the investment tax credit. So you lose a little bit of the potential for the housing tax credits. And use of light tech is optional on solar projects, whether you build it into your base or not. There's also accelerated depreciation available for solar projects, and that usually runs about 10% of the project that is available when you use the investment tax credit. And then it's important to think about, when we think about solar projects, we think, is it make sense just to borrow money to pay for it? And there are a number of very low cost avenues to borrow, whether it's just part of the project's tax exempt bond financing or outside taxable debt. Community debt, some affordable housing folks are essentially crowdsourcing funding at 2.5%. And the Housing Finance Commission has a special sustainable energy trust that loans out at 2 to 3%, depending on the size. So thinking about, can I just borrow more money and pay for solar that is going to pay me every year for the life of the project or the life of the loan? Does that make sense? And I'll show you a tool to help you figure that out. And this probably should come first, but the direct financial benefits are all the power generated over by the system, the value of the electricity, and as I said, is increasing about 3.5% a year in Seattle. So it's actually, after 30 years, it's 2.7 times the current rate. So think about that as an investment. You do need to consider that solar panels suffer degradation over time, about 0.5% a year. So that eats a little bit into the increased value based on the increasing rates, but you still come out way ahead, and your value in 10 or 20 years is still significantly greater than it is today. And then there, what I have just termed indirect financial benefits here. And ESDS, the Evergreen Sustainable Development Standard, requires certain points of which solar can qualify. And also the Housing Finance Commission gives points for solar in their scoring of projects. So those are both indirect financial benefits that could lead to your project getting funding or not funded. So now I am going to, well, I will mention in the guidelines is a guide to using the pro forma I'm about to show you, the Excel spreadsheet, and we'll also make a link to it available as well. So do you see my spreadsheet now? Does everyone see that?
Yes.
Yes, great. Okay, So what this is basically a kind of a what if tool to sort of project what costs and savings could be. And I will walk through it quickly so you can see how it works and what it will do. The orangish cells are sort of required for every project, and the light green are areas where you can override, but there's a typical value plugged in here. So what this allows you to do is to say, I'm going to install a 25,000 watt system or 25 kilowatt system to comply with the Evergreen ESDS, for example. And I want to see what if, I know my roof can handle another 60 kW. So I want to know what happens if I install another 60 kW. It then calculates how much energy you generate from that system. This is the price of power today. This is Seattle City Light. You can adjust it to Puget Sound Energy. The rate increase we anticipate, if you want to be more conservative, you can reduce that. So this is the power generated in year one of the system. And then these are the costs. So as you saw earlier, you can estimate what the cost is per watt. And this should come directly from your solar installer, your building. If they're on board already, if it's a taller building, it might cost more. If it's a difficult location, it could cost more, etc. You see your install price, then you can plug in development costs for the solar specifically if you want. And we've also plugged in an operating reserve that if invested will pay for the need to replace inverters, which happens typically at 15 years once during the life of the project. So those are your system and your costs. And then the sources of money for your project. You plug in here the year you're going to install the project. This is the investment tax credit. It estimates what that is, both on the base and on the incremental, and also the depreciation on both. And then it allows you to layer on the low-income housing tax credits. So you may have a 4% credit, a 9% credit, or you decide you don't want to use it at all. So I'm going to just leave it at 4% for this. And then this is for grants. You can plug in Green Up, for example, at $1.50 per watt. And here you select, this is a grant paid per installed watt. So it calculates at this amount, and it with a maximum of 100,000 kilowatts. And that automatically reduces that. You may have another grant of some kind through utility, or it could just be a project grant from a philanthropy or an investor or so on. Production incentives don't really apply in Washington. We don't have a state incentive program now. The loan will take the difference of what you need to pay for the project and plug it in here. So let's say, you could say, well, I don't know if I want to use my tax credits there. So that would require then a $50,000 loan. You can plug in an annual interest rate and a term, fees. If there's a balloon payment due, which is a way that the Housing Finance Commission can finance, you can use that if there's, oops. Yep. Or you could just have a 15-year loan and then there will be no balloon at all. So that allows you to pay for it, and it uses again, the loan as filling any gap you might have. And then this, if you want to get a little more sophisticated, you can use this. You can assign the cash flow to residents. If in the future we may have virtual net metering, but we don't today. So typically 100% will go to the building owner, and the incentives as well. So for a really, really quick cost effectiveness analysis. This pulls in the first cost, the tax credits, any grants and incentives, and has what's remaining after all of that, and calculates a simple payback. And what's interesting here, you can see the payback on the incremental is much, much faster than the payback on the base. So that is definitely worth considering. And then down below, I won't spend too much time, but this shows the value each year over 30 years of the system. The power production you get and at what value. If you look at the building owner, it then shows you're getting a certain power value. You may be repaying a loan and you have a net benefit each year, as well as a net present value of benefit of $180,000. So you can compare that with other net present values of other investments in the project. And so on. And then this breaks it out to the base and the incremental. So again, the net present value of the base is 49,000 and the incremental is 130,000. And you can see the dollar benefit each year for each. So I'm available to answer questions on this. Hopefully we'll be able to make it easy enough to use that you can use it. I want to emphasize this is a kind of a planning and conceptual tool that you want your legal team and solar advisors and accountants to weigh in and confirm all of this before you get too far down the road. So I know I should have stopped for questions about 25 minutes ago. I'm just going to go to the last piece in our, let me just see here. I think you can see my PowerPoint again. And then the last piece of the guideline is a glossary of solar terms in case someone is trying to snow you with complicated solar terms. So I'm going to stop there and ask Lauren to make sure we open it up for questions. I would just say we have a little bit of fine tuning to do on the guidelines and hope to have them posted hopefully the end of this week or next week at the very latest, along with a link to the spreadsheet. So I'd love to get questions about specifics, but also questions about the guidelines and what you think should be in there that isn't, or what from what you saw was confusing, or what additional information you need. So.
And this is Lauren. I think our group is small enough that if you want to unmute yourself and ask a question, that's fine. Otherwise, you can throw it in the chat and I'll be sure to monitor that.
And I'm going to stop sharing my screen so I can see you all. Any questions?
Steve, I have just one comment and one question. The comment is, just to make sure to really stress checking with your utility that what Seattle City Light may do for net metering may not be the same as what Puget Sound Energy may do, may not be the same as what SNOPUD may do. And we've learned that all the utilities have a little bit different way of looking at net metering. And those things seem to change all the time.
Right. Good reminder. I tend to be Seattle centric. Thanks.
And then a question about you made a comment about direct connection versus ballasted being required. I'm wondering this is the first I've heard of that. And we're starting to do some taller buildings and looking at ballasted systems, and I'm getting nervous.
Yeah, so my understanding is it depends on the projected wind load of a system. So ballasted systems are not permitted when there's a certain wind load. Typically that's, I've been told by solar developers, about 6 stories. So anything over 6 stories, you should question and check that. And then the other key of secured systems is close coordination with the roofer becomes absolutely essential, and trying to make sure you don't invalidate any warranties, but that's all done at the time of install. Yeah. Other questions?
Yeah, Steve, I was going to ask, do you see a future at all where battery storage might be becoming feasible rather than net metering as Tesla's batteries start to become more available and affordable for projects?
Yeah, that's a good question. Yeah. Battery storage tends to only make sense when we have variable electric rates. So essentially, when you can store energy and sell it back to the utility at a higher rate. California has that. We don't have that right now. There is definitely talk about that coming in the future, but it's not today. And therefore, battery storage really doesn't buy you anything because you're getting the full value just through net metering. So we'll keep track of that. The other interesting thing that's happening in some states, in some places, is using battery storage for resilience, and particularly with affordable housing, building community rooms or community venues that have battery storage for use in heating and cooling, refrigeration of medical supplies, and so on. Right now, to make that make any sense, you need to find new monies to bring to the project, typically through philanthropy or some other source. But so excited about battery storage, but there's no financial benefit right now for it in affordable housing. I will say the other thing I've often thought about, and I think people have looked into it, is and would be interesting on a project, is where you're required to have backup power through diesel generator. Can battery storage provide that? And what are the trade-offs there? I guess that's the only other application I've come across for battery storage. And what battery storage would give you then is, unlike your diesel generator, which eventually runs out of diesel, battery storage would replenish itself every day with whatever solar production was available. Other questions? Okay, well, let's, we're going to do a quick follow-up survey. Lauren, why don't we do that, and then we can see if there are any more questions after that.
Great. I'll launch it. Forgive me again, I failed to update this one too. So it asks that how likely are you to consider using, it says wall assemblies in the buildings. Please replace that solar.
While you're voting, I just want to make one other point that I think I neglected to make earlier, and interesting to think about when you're working on a building and thinking of trade-offs and investment in sustainability features. As I said, solar is often looked at as an add-on, but it is, you can also think about it. Is it worth spending an extra $100,000 for this energy efficiency benefit, which has a certain yield, or spending $100,000 on solar, which may have a better yield. So, but often we go through all the energy efficiency first, and I think energy efficiency generally should come first, unless you're talking about, especially on building shell. I don't want anyone not putting things into their building shell, but in terms of advanced equipment or so on, you can think about solar as either a trade-off or an add-on. So hopefully that is another way to think about it. And my goal and our goal in the exemplary building program is to work to provide enough incentives so that solar becomes something you put on a building the same way you do a plumbing system, that we don't think twice about it. It's built in and we get better and better at doing it as a normal course of project development. So the results of our survey look like a few folks were more likely to maximize the solar on their buildings than previously. So the needle moved a little bit. I thank you for that. And I just want to open up to any other questions that people have before we sign off a few minutes early and give you 5 or 10 minutes of your day back. Okay, well, please, I know many of you, and those I don't, can get in touch with me through the Exemplary Building Program. As I said, we'll publish this within a week, and hopefully you all use it and find it helpful. And please continually provide us feedback as some of the rules and regulations change, as John pointed out. So we'll do our best to keep it all up to date. So Lauren, do you have anything else before we sign off? Or
I don't think so. Thank you, Steve, so much for your all your work on this and for the quick turnaround in guidelines. And then just one more encouragement for folks to visit our website and sign up for the remaining workshops.
Oh, and I will also point out the exemplary building guidelines are available at the exemplary building website, which is part of the HDC website. So lots of updates there about projects that have been developed, and all the guidelines will be there. Some of them are there already. So thanks everyone and have a great day.
Thanks, everyone. All right. Thanks, Steve.
Thank you. Take care. Bye.